Hello, this is Math with Beth, and we are going to look at symmetry today with graphs and equations. So when you're looking at graphs, how can you tell if it has symmetry with respect to the x-axis, the y-axis, and the origin? So the x-axis is this line, right? That's your x. So for it to be symmetric with respect to the x, it would need to basically look like the top got flipped to make the bottom. Another way to think of it is this line cutting the graph in half? Or another way to think of it is, would that be like a mirror that would reflect the top to the bottom? So it does not look like it's happening here. But here, do you see that this line does look like it's cutting it in half? This, if it was flipped over, would be here. So this one has symmetry with respect to the x-axis. Okay? So going back to the first one, we did not think it had symmetry with the x-axis, but how about the y? Because it might have symmetry with something else. And yes, you see that the y-axis does look like it's cutting it in half. What's on the left does look like what's on the right if it got flipped over. So this one has symmetry with respect to the y-axis. It could have more than one. So we'll see some that have symmetry with respect to the x, the y, and this origin, but sometimes it's only one. So what would it look like if it had symmetry with the origin? It would look like whatever the graph is got flipped over the origin, which is the middle. So basically it will take it diagonal. So that again does not look like it's happening here, because that would make this end up over here, which it does not. And it is not happening here, but it is happening in this one. If I took this and flipped it over the origin, I'd be over here. So this one has symmetry with respect to the origin. Okay, so that's what they look like. So now let's talk about if we had a point and we wanted to do these reflections. So if I plot the point 2, -3, it would be here. If I wanted to take that point and reflect it over the x, it means flipping it over the x. So instead of being down here, it would flip up top, and it would be the point 2, 3. So do you see what happened when I flipped it? The x value stayed the exact same, but the y value changed its sign. So a way we could write that to kind of remember that rule is when you're flipping over the x-axis, you take whatever your point is, keep the x the same, and change the y. Does that mean our answer is always going to have a negative y? No, this means it will be the opposite of what it was before. So in our case, it used to be a -3, and when we flipped it, it became +3. Okay, let's start back at the beginning again. So go back to 2, -3, and this time what would happen if we flipped it over the y-axis? It would come over here, right? So that would change it to the point -2, -3. So this time, what has changed? The 2 became -2, the -3 stayed the same. So if I wanted to write it as a rule, when you flip over the y-axis, you basically make the x the opposite of what it was before. But the y should stay the same. And then finally reflecting over the origin. If we were at the point 2, -3, which is down here, and I wanted to flip it diagonally, it would become -2, +3. So what changed from the beginning to flip it over the origin? Both. So if I wanted to write a rule, the rule would be that your point should change signs for the x and the y. Again, remember, this does not mean your answer is always going to have two negatives. It just means they're both going to be the opposite of what they used to be. So instead of +2, I'm at -2. Instead of -3, I'm at +3. So reflecting over the x changes the y. Reflecting over the y changed the x. And reflecting over the origin changed both. So if we did not have a graph or a point and we just had an equation, how could we check these things? Well, one way would be to graph it. But what if we don't have a calculator and we don't know how to graph this one by hand because it has some funny things going on? There's an easier way than graphing it if it's something you can't easily graph. So remember our rule. To find out if something was symmetric to the x, remember that we ended up switching the y value, right? So that's exactly what we're going to do with our algebra. We're going to take the y and plug in -y instead. And then we're going to look at what we have now and decide, is there any way this could become what it used to be? So maybe everything had a negative and I could divide everything by -1 and it would look just like it used to. In this case, no, there's nothing because some of the stuff is the same. The 4x squared is still 4x squared, the 8 is still 8, but the y has changed to -y. So there is no way this could become what it used to be, and that's how you decide. So the answer is no, this function would not be symmetric to the x. Not symmetric to the x. So let's do the same type of thing for the y, remembering that the rule we found was that it's the x that changed signs when it's symmetric to the y-axis. So if we go back to the original equation and we plug -x in instead of x, and then see if there's any way this could become what it was when it started. In this case, it can, because when I square this -x, it becomes positive. Remember that when you square a negative number, it becomes positive. So do you see that these are the same? Plugging in the -x did not change the equation. So that's what we're looking for in order to say yes. So this graph is symmetric to the y-axis. And finally, to test the origin, remember we're going to plug in -x and -y and decide. So I'm going to write the original equation again first. And now I'm going to show plugging in -x for x and plugging in -y for y. I put the parentheses here just in case, but it's not really going to be needed. This parenthesis is needed to show that I need to square that -x before I worry about the 4. Squaring a -x just becomes +x squared. So it will now be 4x squared plus a -y. I can just make -y. And now this is similar to our first problem when we were testing out if it was symmetric to x. So this is an equation that cannot be manipulated at all to end up with what we started. So since these are not the same, the answer is no. It is not symmetric to the origin. So those are the 3 tests to find out if something is symmetric to the x-axis, the y-axis, and the origin. If you have any more questions or need to see more of that, you can put a comment or email me and I'll be happy to do more. Bye.